Right, class, we're going to see short illustration to covers learning curve. Alright, now the idea of learning curve, we know that's a theory that believes that every time when production doubles, the cumulative average time we need for a process will reduce at a constant rate. Okay. Now, so I'm going to show how the theory is being applied here onto our calculation. Right, see the first illustration, it says that TC receives orders from customers to produce custom-made souvenirs, and production is highly labor-intensive. Now, of course, learning curve applies to workers. Okay, so there's no learning to machines, you see. Right, for a special order from Simon, the following details been provided to you. Now it says that labor time for the very first unit, which is very important. So learning curve, learning begins from the first unit. So calculation will all based on the first unit. It's 8 hours at the rates of 12. Raw material cost would be $15 per unit. Right, overheads are absorbed on an hourly rate, which is estimated to be $24 per unit for the first unit. Now there's a trick here. It's 24 per unit, but the absorption is on hourly rate. So this shows that rate multiplied by 8 hours for the first unit is 24. So the rate is actually 3 per hour. Okay, right, then they say that 80% learning is expected. The orders would be for 4 units first, 4 units later, and they would like to have a profit markup of 200%. Right, see the requirement says work out the selling price per unit to be quoted for the order, and then how much margin from the first and the second orders from Simon. So margin will actually be the percentage of your profit over your sales. And of course, you believe margin for the first order and the second orders would be different, simply because the cost is changed due to the learning curve effect. Okay. All right. Now, so they want us to calculate the selling price, and they want us to work out the margin. Okay. So in this case, because of the learning effect, that it's actually useful if we have workings to determine the number of hours involved for your production. Now usually if you look at the questions that they have quantity at very low level, like 1 unit, 2 unit, 8 unit, 16 and so on, we can just use this table approach. Now we know that the production, okay, we know that it's the production. Now the learning effects is based on each time when production doubles. So doubles is times 2. So we have 1, 2, and we have 4, then we have 8. And the cumulative average hours per unit. See, the very first unit we need 8 hours, and each time when production doubles, you expect that these will reduce by a constant rate. So the rate is actually 80%. So you're going to expect that 80% of 8 will actually be 6.4 hours. And again, the 80% will be 5.12, and the 80% is 4.096. But again, class, this is the hours per unit, and it's based on average. See, you've averaged because the first unit takes more hour, the next unit takes less hour, but by averaging out, this is what you're going to see. Alright, now we have the total hours for the production that you can determine by just multiplying the units we have here with your average. So you're going to have 8 hours to make 1 unit, and you actually have 12.8 hours to make 2 units. So that 2 units is the first and the second. So when that's the case, we can actually see that the incremental from 8 to 12.8 is actually 4.8 hours. And what is that 4.8 hours? This is the hours that you need to make the second unit. So you can see how hours is cut short from 8 to 4.8 because of the learning effect. Okay, and of course with 8 and 4.8, which is 12.8, the average is 6.4. Okay, and when your production is now increased to 4 units, the total hours is 20.48, and now when your production increases to 8 units, it's 32.768. Alright, so what we actually need is to work out what is the selling price. Now you're going to calculate the selling price by taking a 200% profit markup, and you have to be based on the cost for all the 8 units. Okay, alright, so simple calculation. Now I'm going to work out the cost for the first 4 units, cost for the next 4 units, and the total cost of 8 units. Now we need all these for the answers later on. Alright, now in terms of the labor, so I'm told that the labor will cost $12 an hour, and to make the first 4 units, hours involved is 20.48. But when it comes to the next 4 units, the hours taken will actually be the incremental from 20.48 to 32.768. So it's actually 12.288. Right, so we actually have 245.76, 147.456. Right, the overheads will be absorbed based on $3 an hour. So basically you just convert it back. So just take the cost you have here, divide by 12, and then multiply by 3. Okay, so divide 12 multiplied by 3. That's my cost. That's my cost. So this is my overheads. Right, the cost of raw mat is actually based on 15 per unit. So if you want to add, you can just add all the $60 for all the 4 units. Right, that's my total cost for the first 4 units. Right, I'm going to round this to the nearest dollar. So this is 367. This is 244.32. So it's 244. So all the costs of the 8 units will actually be 611. Alright, so this is what we need for the calculation. So how much price are you going to quote? So the selling price. Now you're going to take a 200% profit markup, which means the selling price will be your total cost of 611, your profit markup is 200%, so it's 1,222. So you're expecting 1,833, and we're actually looking at 8 units. So your selling price per unit will actually be 229. Now if you're gonna sell a 229 for a unit, so how much will your profit margin be? Right, for the first order and the second order, your sales will actually be 916. Your total cost is 367,244. Right, this is giving us a profit of 549 and 672. So what is margin? Now margin is what we have over your sales. So if that's the case, if you have A and B, so B over A, our margin is 60% for the first order, and our margin is 73% for the second order. Okay? Alright, so this is how the learning curve is being applied in this situation. So this is the first case. So basically we're just telling you that each time when production doubles, you expect your cumulative average will reduce at a constant rate. Okay? Now, so the next thing that we're going to see in learning curve is we know that this so-called the average hour, the cumulative average hour, whether it's per unit or per batch, and of course you can replace hours with your costs, can actually be determined with this formula that y equals to dx, ax squared. Okay, so what is this? This is the cost or the hour, depending on whether you apply cost here, then you must use cost here. If you apply hours here, you use hours here. For the first unit, or of course, or the first batch, times, now if you want to find the average for whichever production level, so this is where your quantity comes in, power of B. Now what is B? Now your B will actually be your log learning rate divided by log 2. Okay, so your learning rate, if you give 90%, then you just start log 0.9 divided by log 2. Okay, now we're going to see how this is applied using the second illustration. Right, say Roland produces A, which involves a labor process and production details for the very first unit, the very first batch of A, it's based on batch. Now one batch is 100 units, and they tell you that 20 minutes is required for the unit. Now if that's the case, we actually 20 out of 60 times 100, so we have 33.33 hour in the first batch. Okay, now the 90% learning rate is expected for production up to 40 batches, and thereafter the time for the 40th batch will apply for the rest. So that means that learning effect will stop once it has reached 40 batched. Now Roland has carried out the first production run of 20 batches. Now you know that learning effects is cumulative. That means that the 20 batches of production has been carried out. And now they're preparing the cost information for the next production run of 60 batches. So now that this 60 batched, how many hours do you need? Right, if you want to try, then just pause the video and then you just do your own calculation, okay? Right, so we're going to tell you and explain over here. Now, the learning effect started for 20 batches. So now, for the next 60 batches that you need to estimate, you got to understand that there's only another 20 batches that learning will apply. And the remaining 40 batches, there will be no more learning. So how much time do you need for these 40 batches? Now you will need to know what is the actual time you need for the 40th batch multiplied by all the 40 batches. And what about the time you need for these 20 batches? Now because learning applies, so what you can do is you can calculate what is the total time you need for all the 40 minus the total time you need for the first 20, which is here, and then you're going to get a question mark, okay? So it's going to be tedious in the sense that you're going to work out quite a number of calculations here and there, okay? But it's not difficult. Alright, so the labor hours for the next 60 batches. Now, if I take the total hours for the first 40 batches minus the total hours for the first 20 batches, this will give me the total hours for the second 20 batches, and that second 20 batches is this, okay, because you have actually started. And why we take 20? Because we know that the learning effect is stopping at the 40th. So this is what we're going to do, and we're going to add the total hour for the next 40 batches. So that will give us the total hours for the 60 batches of production. So this is where the next 40 comes in. Alright, so what's your total hours for the 40 batches and the 20 batches that we have here? Now you just got to find y multiplied by 40 multiplied by 20, because here we are looking at the average hours per batch. So the formula you're going to use is y equals to ax power of b. Alright, so I'm going to use the 1. So the hours for the first batch is 33.33 and multiplied by 40 power of log 0.9 divided by log 2. Right, so that is giving us a value of 19.02467. So this is 7609868. Alright, now what we need here is quite simple. You're just replacing 40 to 20, and the power of b is the same. So by just changing this to 20 instead of 40, the average is 13,853. Now that's giving us a total hours of 422,706. Now, so that's the total hours you need to make all the 40 and to make the first 20. So the difference will be the hours for the balance 20. That means batch 21 to batch 40. So that hours requirement is 338.2162. Now what about the balance of the 40th batches? Now this is where learning has stopped. Now once the learning has stopped, you must find the actual hour at the 40th batch and you multiply with the balance of 40. So what's the actual hours? Now basically the actual hours will be the total hours for 40 batches minusing the total hours for 39 batches. Agree? So the difference from 40 with 39 is the actual for the 40th. Now, so the 40 batches is 7609868. So what about 39? So it's going to do the same thing. You're just going to replace the 40 into 39, factor by the same power of b, and you're looking at 39 batches. So what we're going to see here, (33.33 power of log 0.9 divided by log 2. Now this will give us 19,09803, and we're gonna get 7448232. But that is the difference, 16.1636. So the actual hours we need once you've reached the 40th batch is 16.1636. So at the end, total is this. So how many hours do we actually need to make all the 60 batches? So the actual hours in total is 94,7602. Alright, so class, again, the issues about learning curve is not difficult, but the issue is complicated by the fact that you need to do quite a number of adjustments, because at one time you will need to know you're going to use an average hour, at one time you're going to use an actual hour, you're going to know whether the learning has started or the learning has stopped, and all these things is what you must be very careful, okay? So if you master all these adjustments, I believe basically you can handle all situations, right? So again, thank you class, so happy revising.